In this module, we'll introduce you to some high-level concepts on how SD-WAN works. But first, let's take a look down memory lane and talk about the wide area network. In order for us to discuss SD-WAN, we first need to go back to the beginning. It's probably safe to say that for most people, they used the internet before they knew what it actually was. To most, it is just the cloud. They accessed it by playing a game on mom's tablet, watching a streaming video from home, or something similar. Being older, my first exposure to the internet was at work. I was a bank teller, and we had multiple locations with multiple users, and they needed to all be connected. Nowadays, anyone who uses a computer for work utilizes the internet. Usually, users were located at a particular site of the business. Think of a local clinic or regional hospital, a regional check processing center or branch of your local bank, as well as the headquarters of both, consisting of administration, accounting, sales. Get the idea? From a networking point of view, each of these sites is considered a LAN, or local area network. Yet do you realize that your home even is a LAN? Some of you may even remember a time before Wi-Fi, where if you connected to the internet via DSL or cable modem, everything needed to be cabled through it. When home Wi-Fi became available, we added a Wi-Fi router to extend our LAN to wireless devices, and of course now, the Wi-Fi router and modems are normally a single device. So the LAN is usually a private network that connects computers or hosts, whether it be at a home or in a business, to each other within the same location. Hosts can be thought of as any computer device that is connected on the LAN inside your network. It's not just limited to your computer, but any smart device, a refrigerator, gaming console, smart thermostat, router. For businesses, it's not that different. The LAN is essentially all the devices connected for that business to connect to the internet, the outside world. For a bank branch, it could be the bank teller terminals, ATMs, loan officer PCs, even phones if using voice over IP. A LAN can also connect different floors of a building, or different buildings of a hospital campus. Each of these LANs had to be connected to each other. Each of these LANs is part of the internet. The rest of the internet is, you guessed it, the wide area network. Now let's zoom into more of what is the wide area network, or WAN. Essentially, this is the part of the internet which connects different LANs or private networks together, whether they be different service providers, companies, or again, even your home. For all intents, the public internet is the wide area network. Traditionally, meaning roughly the past 2+ decades, WANs were based on conventional routers which were never designed for the cloud. This conventional router-centric model distributed the control function across all devices in the network and simply routed traffic based on TCP/IP addresses and access control lists. This traditional model was rigid, complex, inefficient, and not cloud-friendly, which resulted in a poor user experience. They typically required backhauling all traffic, including cloud-destined traffic, from branch offices to a hub or headquarters where advanced security inspection services could be applied. The delay caused by backhaul impairs application performance, resulting in a poor user experience and lost productivity. So, all the business locations, such as branches, regional offices, and even HQ, where more than 80% of business transactions are handled, were connected to a headquarters-based data center by a router over a leased line connection, usually MPLS. And that model was fine back then because all applications were hosted in enterprise data centers. In addition to IP addresses and ACLs, traffic was also routed using complex routing protocols like BGP. All of the control functions were distributed across all of the routers. In the past, we installed software like Office, QuickBooks, Photoshop, Call of Duty on individual computers, each requiring their own individual licenses. Today, most, if not all of them, require cloud connectivity, so licenses can be applied to users, allowing use by that user from any device, anywhere. Heck, I must have watched Top Gun a dozen times or so via DVD. Last week I watched it using Paramount Plus before watching the sequel. Well, don't you think the same thing has happened for businesses? Of course. Traffic patterns have changed with the introduction of applications moving to the cloud. This could be enterprise apps that are now hosted in Amazon Web Services or Azure or Google Cloud, or software as a service, SaaS apps like Salesforce.com, Workday, Office 365, Facebook, and more. Sending cloud traffic that is destined to Office 365 via MPLS to the data center, then having that exit out to the internet to reach the Office 365 servers simply doesn't make sense. It adds delay that degrades application performance and consumes costly leased-line bandwidth. Branches are already directly connected to the internet. Why not use their direct internet connections to reach Office 365 servers directly? This has driven the need for a more intelligent, software-driven, or software-defined model for the WAN, an SD-WAN. Unlike the traditional router-centric WAN architecture, the SD-WAN model is designed to fully support applications hosted in on-premise data centers, public or private clouds, and SaaS services, while delivering the highest levels of application performance. So how does an SD-WAN work? An SD-WAN enables cloud-first enterprises to deliver a superior application quality of experience for users. Firstly, by replacing existing equipment like traditional edge routers, which often included specialized ASICs, unlike today's SD-WAN implementations which run on off-the-shelf hardware, as well as virtual instances on industry-standard servers and even in public cloud services. SD-WAN appliances can provide intelligent application-aware routing across the WAN. Instead of routing traffic just based on TCP IP addresses and access control list tables, an SD-WAN is application-aware. It uses software to more intelligently route or steer traffic across the WAN based on the business requirements for an application. These include the priority of the application, the performance required, and the security policies that must be enforced. Enterprises can now leverage any combination of transport services, including MPLS, LTE, and broadband internet services, to securely connect users to applications. Each class of applications receives the appropriate QoS and security policy enforcement, all in accordance with business needs. Secure local internet breakout of infrastructure as a service and SaaS application traffic from the branch provides the highest levels of cloud performance, while protecting the enterprise from threats. That improves business productivity and lowers costs. As we mentioned, no longer is a traditional router sufficient. Enterprises are using the cloud and subscribing to SaaS apps like Office and RingCentral and the like, while users traditionally connected back to the corporate data center to access business applications. They are now better served by accessing many of those same applications and locally breaking it out to the internet directly. As a result, the traditional WAN is no longer suitable, mainly because backhauling all traffic, including that destined to the cloud, from branch offices to the headquarters introduces latencies and impairs application performance. SD-WAN provides WAN simplification. Consistent security reduces business risk via the use of IPsec tunnels. When traffic between different branches of an organization needs to be exchanged within the business network securely. SD-WAN architecture decouples or logically separates applications and the control and management functions from the WAN transport services like MPLS, broadband internet, LTE, or even satellite and microwave. In SDN speak, this is referred to as the separation of the control or management plane from the data forwarding plane. And again, this is a very different model than the traditional router model, where this was all combined in every device. With an SD-WAN, the control function, referred to as the control plane, is centralized. And with a software model, adding locations, adding applications, changing policies, all of that is much easier than with the old router-centric model, which makes an SD-WAN the more intelligent, cloud-first way to build a WAN. A good SD-WAN becomes application-aware and makes decisions based on the type of traffic being forwarded instead of simply its IP addressing. The quality of service and security policies that dictate how an application should be delivered to the user are defined centrally. And, with automated provisioning, configurations and policies are programmed once and pushed to tens or hundreds or even thousands of branch locations without having to manually program each device. This eliminates the truck roll or need to send specialized IT resources out to branch locations whenever a new app is added or a policy is changed. Many SD-WAN solutions are basic SD-WAN solutions or just good enough solutions. These solutions lack the intelligence, reliability, performance, and scale needed to ensure a superior network experience. And remember, without a fast, secure, and high-performing network, enterprise digital transformation initiatives can stall because they rely on apps that rely on services that in turn rely on the network. SD-WAN is a pivotal digital transformation enabler and is driving strategic decisions across the enterprise. So what is a business-driven SD-WAN and why is basic SD-WAN not good enough? A business-driven SD-WAN provides lifecycle orchestration and automation. Basic SD-WANs do not always provide full end-to-end orchestration of all WAN edge functions, such as routing, security, including service chaining to advanced third-party security services, and WAN optimization. Continuous self-learning. A basic SD-WAN steers traffic according to predefined rules, usually programmed via templates. A business-driven SD-WAN delivers optimal application performance under any network condition, or changes including congestion and when impairments occur. This dynamic approach through continuous monitoring and self-learning allows a business-driven SD-WAN to respond automatically and in real time to any changes in the state of the network. It provides consistent quality of experience. A key benefit of an advanced SD-WAN solution is the ability to actively use multiple forms of WAN transport simultaneously, bonding these tunnels. Basic solution can direct traffic on an application basis down a single path. If that path fails or is underperforming, can it dynamically redirect to a better performing link? A business-driven SD-WAN intelligently monitors and manages all underlay transport services. It can overcome the challenges of packet loss, latency, and jitter to deliver the highest levels of application performance. Unlike a basic SD-WAN, a business-driven SD-WAN handles a total transport outage seamlessly and provides sub-second failover. You get end-to-end micro-segmentation. While a basic SD-WAN provides the equivalent of a VPN service, a business-driven SD-WAN provides more comprehensive end-to-end security capabilities, in addition to supporting things like a stateful zone-based firewall. An SD-WAN platform should orchestrate and enforce end-to-end micro-segmentation spanning the LAN to WAN and data center, and the LAN to WAN and cloud. And finally, you get secure local internet breakout for cloud applications. Many basic SD-WANs provide some application classification capabilities based on fixed definitions and manually scripted ACLs to direct SaaS traffic directly across the internet. However, cloud applications change constantly. A business-driven SD-WAN continuously adapts to changes and provides automated daily application definition and IP address updates. This eliminates application interruption and user productivity issues. The SD-WAN enables the use of multiple WAN transport services like MPLS, broadband, and LTE. Some more advanced SD-WAN platforms enable use of multiple transports, even to carry traffic for a single session, like a phone call, video conference, or business transaction. Adding bandwidth can increase the performance of an application. Using multiple transport services for the same app improves availability because even if the one transport service fails, the remaining ones continue to carry the application session. The business keeps running, uninterrupted. Now this means better productivity and a better quality of experience for both employees and their customers. Now let's look at agility and responsiveness. 3 key capabilities of the best SD-WANs are centralized orchestration, zero-touch provisioning, and the ability to reliably and securely use internet services. This means that a new branch office can be brought online much more quickly and without the need to send specialized IT resources into the field. An office manager simply plugs in the SD-WAN appliance at the branch, connects the LAN and WAN ports, and then it's hands-off. zero-touch provisioning takes over to authenticate the device and configure it remotely. And while MPLS services might take 60 to 120 days to provision, broadband internet services are available almost anywhere in a matter of days. A new branch can be brought online far more quickly than previously possible. And the same goes for adding a new application or changing a QoS or security policy, which means faster time to revenue for a new branch location, or perhaps a new business unit that was added as the result of an acquisition. 3 or 4 years ago, reduced cost was often the first benefit customers looked for when considering SD-WAN. Fast forward to today, where other benefits such as increased application performance, business agility, and improved security are far more important considerations for companies looking to adopt SD-WAN. Still, the ability to use lower-cost broadband to augment or even replace MPLS, and the ability to simplify WAN architecture and security can drive substantial cost savings over time because an IPsec VPN over an internet link is very secure. Now, you might think that by adding the internet as an active transport for the enterprise WAN can compromise security, and with the wrong SD-WAN solution, that would be true. But the right SD-WAN can provide end-to-end segmentation that can separate or isolate voice traffic from point-of-sale traffic, from HVAC applications and guest Wi-Fi. This robust end-to-end segmentation could have prevented many of the security breaches we've all read about. We're also seeing the rapid adoption of cloud-hosted security services that provide more comprehensive, more consistent security enforcement via an on-premise security solution. Security delivered in the cloud is easier to keep up to date with the latest threat and vulnerability protection definitions, and this is in contrast to the traditional model, where every firewall needed to be updated daily. An SD-WAN vendor that seamlessly integrates with cloud-hosted security services can provide better cloud application performance without any compromise in security protection. For the CISO and the rest of the C-suite, this means reduced business risk and increased brand protection. Can you recall the huge drops in stock prices of companies that have suffered security breaches? So in summary, the right SD-WAN choice can unify all essential WAN edge network functions in a single platform, including routing, firewall, visibility and control, WAN optimization, and of course SD-WAN. Besides reducing the hardware footprint and power consumption at every branch, centrally orchestrating all of these functions greatly simplifies WAN infrastructure management for IT and provides a more consistent QoS and security policy enforcement across the enterprise. For the C-suite, this means reduced risk and of course reduced capital and operating expenses for the WAN. Let's answer some questions now to see what you got out of this module.